last lecture we had talked more about functions, and we had introduced the notion of scope and lifetime, and we had talked about global variables, etc. And finally I had left you with a problem to think about, and that problem was to write a program to find a path through the maze. I hope you spent some time thinking about the problem. So let's just review the problem once again. We want to write a program to find a path through the maze. The maze is represented as a grid of characters, a two-dimensional grid of characters. A star in the grid represents a part of the wall where one cannot go, and a blank space represents an open space where movement is possible, and an entry point into the maze is given by the user as an x, y value. And remember that we had said that if there is any other exit in the maze, then the path should take one from the entry point to some other exit in the maze, and if there is no other exit in the maze, then the path should bring one back outside the maze through the same entry point. And this, remember, was our representation of the maze on the xy plane. The stars represent walls and these blanks represent open spaces, and assuming this is the entry point, this is the path that the program should tell us to take. So in terms of the coordinate system, this path turns out to be this. Now this problem might look to be complicated, but as it turns out, it has a very simple algorithm to solve this problem. I'll give you the algorithm, and I'll leave you to convince yourself that this algorithm works in all cases. So the algorithm is very simple. So we start at the entry point, and as long as we are not outside the maze, that is, as long as we are somewhere within the maze, we do the following. So this entire thing is one step in the path. So we have to maintain a current sense of direction. The direction could be north, south, east or west. The first thing you do at any place in the maze, you turn right, and then if you are facing a wall, turn left. If you are still facing a wall, turn left again. If you are still facing a wall, turn left again, and so on. So as long as you are facing a wall, keep turning left. Note that you can't turn left more than 4 times, because then you will be facing in the original direction, and if you were if you had come to a particular point from some direction, then there is at least one way to move from the current point, which is to go back in the direction from which we had come. So when this loop terminates, then step forward in the current direction. So essentially, while we are turning, the direction is changing. Now the reason this algorithm really works is that by trying this, we are trying all possible 4 directions and seeing which way we can go. But we are trying these 4 directions in a certain order. So if we reach a dead end, and then this loop will make sure that we turn back and come back to some place which we had visited earlier, and then later on will not go back to a path that we have already visited once. That's because when we come back to the same place, we will be facing in the reverse direction as compared to the direction in which we were facing when we visited this particular place the first time. So this is of course a very intuitive explanation of why the algorithm works. I would like to encourage you to take some examples and see for yourself that the algorithm indeed works. And the nice thing about the algorithm is that if there is no path in the maze from the entry point to some other exit point, then it will plot a path which brings you back to the original entry point. Okay, so the algorithm is straightforward enough. Now we have to focus our attention on how to implement this algorithm as a program. And the first thing that we have to worry about for implementing this as a program is how we are going to represent a maze. Okay, so the obvious answer to that is that we represent the maze as a 2-dimensional array of characters, right? Because it's a 2-dimensional grid, and each character in the array at any ij location would either be a star character, which represents a wall, or a blank character, which represents an open space, right? So maze xy, suppose maze is the name of the array, would represent the maze character at position xy. Now since we will also finally go outside the maze, and at other places we will check whether we are facing a wall or not. Now when we are checking whether we are facing a wall or not, we are going to be at we may be at the edge of the maze, and the direction we are facing is outside the maze. So if we have to check that the character facing us is a wall or an open space, we have to make sure that we do not violate array bounds. Remember that it's very important that when we access an array element, the index or the indices that we specify for the array element are within the bounds of the array. So we have to make sure that even when we are outside the maze, or when we are on the edge of the maze and we are checking and we are facing outside the maze and we are checking whether we are facing a wall or not, we have to ensure that we never violate the array bounds. And to make sure that we never do that, what we are going to do is to create an open path all around the maze. So let's say the user gives us a maze of size 5 by 5. What we are going to do is to convert that maze into a maze of size 7 by 7, and in the center of this 5 by 5 maze, the original maze given by the user is placed, and all around it on all 4 directions there is an open path. So let me show you what I mean. So let's say this is the maze that the user has given us. I have instead of putting blank characters, I have put the dash character just to show you that these characters exist. Now around this maze we are going to put a 1 character thick open path. So this path we have created outside the maze on all 4 directions. So the idea is that even if from this point we come out here and we are at this location, the x and y positions are still within the bounds of the array. And similarly, for example, if we are here and we are facing towards the south, assuming that downwards is south, and we want to check whether we are facing a wall or not, then we'll have to check this character in the maze. Now if the array is only till here, then this index would be outside the bounds of the array, and we'll have to put special checks to ensure that we do not violate the array bounds. By putting an extra path all around the maze, we avoid those kinds of complications. So the net result is that the size that we'll declare for the maze will be 2 more than the actual maximum size that we want to permit. Okay, let's now try to develop a program for this, but let's first look at a design for this problem. This is a reasonably complicated problem. So here is a possible what is known as functional decomposition of the problem. That is, we can identify these distinct and independent subproblems, and so what we are going to do is to define functions for each of these and then put together these functions and use these functions in the main program to solve the overall problem. So the first function is read maze, which will read the maze from the user. The second function will be read starting position, which will read the starting or the entry point of the user. Note that we need to make these into functions, because even though the complexity, even though the functionality of these functions might appear simple, it's actually a little bit more complex, because we want to make sure that the input given by the user is always consistent and it's not invalid, and so on and so forth. And so, as you will see, we need to make a large number of checks on the user supplied inputs, and that's why we prefer to make these into independent functions. The next function is outside maze, which will just tell us whether we are currently outside the maze or within the maze. And you can see that this function would essentially check whether our current position is on that border around the maze, that is somewhere on that border around the maze that we had created. If it is on the border, then we are outside the actual maze, otherwise we are inside it. The next function is facing wall, which will tell us whether we are currently in the current direction, what we are facing is a wall or not. So if we are facing a wall, we cannot move ahead. And then functions turn left and turn right, which will change our direction appropriately. The step forward function will move us 1 step ahead in the current direction, and that will change the current position that we are at in the maze. And finally, the function print position will use to simply print one position in the path. So at each step in the path will print the current position. So we need to write all these functions, and as you can see that most of these functions are going to use number of large amount of common information. So all of those will define as global variables. So these are the global variables we are going to need. The maze itself, which is going to be, as we said, a two-dimensional array. And then the actual size of the maze as opposed to the maximum size of the maze that we can accept. So in the size x will be the actual size of the maze in the x direction, and size y will be the actual size of the maze in the y direction. And pos x, pos y is the current position within the maze, at what point we are within the maze at any given step. And finally direction is the direction that we are facing at the current moment, which could be north, south, east or west. So let's now put together these ideas in the form of a program, and using a bottom-up approach, let's develop these functions one by one, and then finally put these together into an overall program. Okay, so let's now look at the program for solving this maze problem. So we start with some constant and global variable declarations. So this max maze size is a constant which says what is the maximum size of the maze that the user can give. So this is in the x direction as well as the y direction. So we have defined this to have the value 20, meaning that the maximum maze size can be 20 by 20. And then we have defined these four constants for the four directions, north, west, south and east. They could have been defined to be any numbers as long as they are distinct numbers. Now these are the global variables that we had already identified for the program. The maze is a two-dimensional array of characters of size max maze size plus 2 into max maze size plus 2. The direction is the current direction we are facing, which will be one of north, west, south and east. Pos x and pos y are the coordinates of the current position within the maze, and size x, size y are the actual maze size in the x and the y directions. So let's now look at the function read maze. That's the first function. So we first ask the user to enter the maze size and read the sizes in the two directions, size x and size y. Note that we store the return value of scanf in a local variable r, and now we need to check whether the user supplied input for the maze sizes is correct or not. So if the value of r is not equal to 2, that means he did not really enter two integers, and therefore an error message should be printed. Or if the x size or the y size is more than max maze size, then the size he has specified for the maze is too large and we can't handle that, so again we should give an error message. Or if the maze size in either direction is too small, maze of size less than 2 does not really make sense, then also we should print an error message. So in any of these circumstances, we print this error message that the maze size that was entered was invalid, and then we use the library function exit here. Now this is a function that we are seeing for the first time. So this exit function is a library function which causes the program execution to terminate immediately. Note that this is different from the return statement in that the return statement causes the currently executing function to immediately return, but calling the exit function causes the entire program to terminate immediately. The argument to the exit function is an integer which we have specified as 1 here. So this argument to the exit function is a kind of exit status of the program, and usually the convention is that if the program terminates successfully, then it should exit with an exit status of 0. Otherwise, if it terminates due to some kind of error condition, then it should exit with a non-zero exit status. So since in this case we are exiting because of an error in the input, we are supplying a non-zero value for the exit status. Okay. So after having read the size of the maze, we'll need to read the actual maze. But before doing that, we need to be careful, because the first line of input that the user entered contained the two integers and at least the return character or the end of line character after that. Now we are going to use the getChar function for reading the configuration of the maze, that is for each position in the maze, whether it contains a open space or part of a wall. So in the getChar library function, recall that it does not skip any character in the input. So suppose the user entered 5 and 5 for the size of the maze, and then he entered the return character. Now if we now read the next character, we'll see the new line character as the value returned by the getChar function. Now this is clearly not part of the maze itself, so what we need to do is that whatever the user entered on this line after the second integer and till and including the new line character, that needs to be skipped. So that is precisely what this simple while loop is doing. Note that the body of the while loop is empty. It has just this empty statement in it. So the body is not doing anything. All the action is actually happening in the condition itself, which has the side effect of reading a character, because it is calling the getChar function. So as long as we read characters, as long as we don't see a new line character, and we stop reading characters when you have seen a new line character. And the effect of that is that on this first input line, whatever the user entered after the second integer till the new line character, all these characters are read from the input and they are discarded. So the next character that we read from the input will be the first character entered by the user on the next line. So after doing that, we prompt the user to start inputting the maze, and this big loop reads the maze. Now how are we going to read the maze? As I said, we are going to use the getChar function to read individual characters in the maze. Recall that our x and y directions were like this. So the user is going to give the maze configuration in this fashion. That is for he will first supply the entire row for y equal to 1, and then the row for y equal to 2, and so on and so forth. The y equal to 0 row in the array we will reserve for the path that we are going to create around the maze. So for each successive value of y from 1 till size y, we have to read the entire row of maze characters, and the number of characters there is size x. So for x from 1 to size x, we read the maze character at the position xy using the getChar function, and now again we make sanity checks on the input that we have just received. So the maze character that we have just seen should either be a star character indicating a wall, or it should be a blank space character indicating an open path. So if the character that we just saw is neither star nor the blank character, then again we print an error message that an invalid character in the maze was entered by the user, and we specify in the bracket what character was found to be invalid, and then we exit from the program. So once this inner loop terminates, we have read all the characters in a particular row, and then at the end the user of course terminated this line by hitting the enter key, which means a new line character is also there. So now if we immediately start reading the next row, the first character that we'll read will be the new line character, which of course would be an invalid character. So what we need to do is to discard again this new line character, and that we are doing by calling getChar one more time to discard the end of line character at the end of the line. Okay, so after having read the maze, now our array is of size let's say 7 by 7 if the size x was 5 and size y was also 5. And what we have done is that we have read this part of the array from the user, and this part of the array outside this has to be initialized to a to an open path. Now note that this part of the open path will have the value y equal to 0 and x will range from 0 to size x plus 1, and similarly this portion of the path will have y is equal to size y plus 1 and x again will range from 0 to size x plus 1. Okay, and similarly these two paths will have the same y but will have the same x but different values of y. So this first loop is initializing these paths in the north-south directions on the two sides of the maze. So essentially what we are doing is for x equal to 0 and for x equal to size x plus 1, we are initializing all elements of the maze to the blank character for y from 0 to size y plus 1. Note that the loop runs till y is less than size y plus 2, which means that y is less than or equal to size y plus 1. And then this loop essentially initializes these two parts of the path. So now we have created the open path around the maze also. There is nothing else to be done in this function. So the function finishes. Note that there is no return statement. Return statement, as we had discussed, is not needed for functions that do not have any return value. When the function body finishes, then the function automatically returns. Okay, so here is the next function that we had identified, namely read starting point. So again it has no parameters and has no return value. It will read the starting point and store the starting point in the variables pos x, pos y, which are declared to be global variables. So again it asks the user to enter the starting point and reads two integers into pos x and pos y, which are global variables, and again stores the return value of scanf into the local variable r. So if the value of r is not equal to 2, or if the starting position is not a valid starting position, then we want to print an error message and exit from the program. What do we mean by a valid starting position? Well, the starting position must be on the boundary of the maze. So first of all, what we are going to check is that pos x and pos y have valid values. That is, pos x must be at least 1 and pos x must be no more than size x, and similarly pos y must be at least 1 and pos y must be no more than size y. And then we are checking that the starting point that the user has specified, at that point in the maze there is an open space, because if at this place there is no open space, then this cannot be a starting point. And then this last check ensures that the starting point is indeed on the boundary of the maze. So a point is on the boundary of the maze if either x, the value of x is 1 or size x, or the value of y is 1 or size y. So if the value of x is 1, then it is on this border of the maze somewhere. If the value of x is size x, then the starting point is somewhere on this side of the maze. If the value of y is 1, then the position is somewhere on this line, and if the value of y is size y, then the starting position is on this edge. But if it is on neither of these four edges, then the starting point specified is somewhere inside the maze, and that's obviously not permitted. So therefore, if pos x is not equal to size x and pos x is not equal to 1 and pos y is not equal to size y and pos y is not equal to 1, then the starting point that the user has specified is again invalid. So in that case also we print the message that it's an invalid starting point and terminate the program by calling the exit function. So we print that it's an invalid starting point and then we terminate the function by calling exit. So now if we reach this point in the program, that means that the starting point entered by the user was a valid starting point, and now we need to initialize the initial direction. Now how do we initialize the direction to begin with? Well, that's again simple. If the starting position is somewhere here, then the initial direction must be south. Similarly, if the starting position is somewhere here, the initial direction must be west. If it is here, then it must be north, and if it is here, then it must be west. So if pos x is 1, that means the starting point is like this, somewhere on the left edge of the maze. Then the starting direction is east, this way. If pos x is equal to size x, then it's a situation like this, and the starting direction is west, this way. Similarly, if pos y is 1, then it's a situation like this, and therefore the direction is south. Otherwise, it must be the case that the starting point is on the bottom edge of the maze, because if it is on neither of the 4 edges, we would have not accepted that starting point at all. So in this last case, the starting direction would be north. So after having computed the starting direction in this way, the function simply returns. All the initializations it needed to do have been done. Let's now look at the next function, which is turn left, and this is quite simple. Depending on the current direction, just the direction changes, the position within the maze does not really change. So if right now we are facing north, then on a left turn we'll start facing west. So if the direction is north, the direction becomes west. Similarly, if the direction is west, if we take a left turn, we start facing south, and if we were initially facing south, then on taking a left turn we start facing east. And otherwise, if the direction is neither north, west or south, then it must be the case that the direction is east. So on a left turn, the direction becomes north. The turn right function is exactly similar, except that from north we go to east, and so on and so forth. So the next function is to determine whether we are in the current position and in the current direction facing a wall. So this function is supposed to return true if we are facing a wall, and false otherwise. So again, there are no parameters because all the information that we need is available in global variables, but there is a return value which is true or false, and in C, as you know, there is no boolean type, so we use the integer types to represent booleans. So we have declared the return type as int. Now how do we determine whether we are facing a wall or not? Let us say we are facing in the north direction, that is the current direction is north. Then if this is the current position, then if we go one step north, the current position, then the new position will become x comma y minus 1, because x will remain the same and y will get decremented by 1. Now if whether we are facing a wall or not depends on whether the maze at this new position, had we moved one step north from the current position, this new position, whether it contains a wall or not. So if maze pos x pos y minus 1 is equal to star, that means we are facing a wall, otherwise we are not facing a wall. So note that what we are returning is the value of this entire expression, and the value of this entire expression is true if the maze element at pos x pos y minus 1 is star, and it's false if the maze element at this position is a blank. So that's precisely what we are supposed to return, and therefore this is the correct return value. Similarly, if the direction that we are facing is west, then if we move one step west from the current position, then the new position would become x minus 1 comma y, and so what we return is whether maze pos x minus 1 pos y is equal to star or not. Similarly, if the direction is south, then moving one step in the south direction would lead us to x comma y plus 1, and that's what we return here, whether that new position contains a wall or not. And similarly, else the direction is east, this should be east. So if we are facing east, by moving one step we would have reached x plus 1 comma y, and so in this case we return the result of checking whether at that new position the maze contains a wall or not. Okay, the next function is to determine whether the current position is outside the maze or not. So again, there are no parameters because all the information required is available in global variables, and the return value is of type int because we are going to return true or false. So how do we determine whether we are outside the maze or not? All we have to check is whether we are somewhere on this path that we had created around the maze or not. And so if pos x is 0, note that the actual maze runs from y equal to 1 to y equal to size y, and in the x direction from x equal to 1 to x equal to size x. So if the current value of x is 0, that means we are somewhere on this path, or if the current position of x is size x plus 1, then we are somewhere on this path, and if the current value of y is 0, that means we are somewhere on this path, and if the value of y is size y plus 1, then we are somewhere on this path. So in all these cases we are supposed to return true, and that's what precisely this expression consisting of or of these multiple conditions will do. So if pos x equal to 0, then this entire expression whose value we are returning will evaluate to true, and similarly if pos x is equal to size x plus 1, then this expression evaluates to true, and therefore the entire expression also evaluates to true, and so on. And in all other cases the expression representing the return value evaluates to false, and so therefore we end up returning the right value. So that's almost the end of the program. You just need to write a couple of simple functions. So the next function is to step forward from the current position in the current direction. So all we need to do is to change the value of the current position either in the x direction or in the y direction, depending on whether we are facing west, north, south or east. So if we are facing north, then by moving one step in this direction, the value of y will get decremented by 1. If we are facing west, then the value of x will get decremented by 1. If we are facing south, then the value of y will get incremented by 1. And if we are facing east, then the value of x will get incremented by 1. Remember that our coordinate system is like this: x is increasing this way and y is increasing southwards. The next function, print position, is equally simple. All it does is that it prints the current position pos x pos y in this notation. So if the current position happens to be 3 and 2, that is pos x equal to 3 and pos y equal to 2, then this function will print something like 3, 2 with a blank after the bracket, so that if we successively print multiple positions within the maze, they are separated by blank spaces. So finally we are in a position to write the main program, which will just call all these functions that we have written. So in the main function we first read the maze. Note that the main function does not really require any local variables at all. We first read the maze, then we read the starting point, then we print the current position, and then essentially this loop captures the algorithm for this problem that we have already seen. While we are not outside the maze, turn right, and then while facing a wall, turn left, and then step forward. And then since we have stepped forward, we have moved to a new position, so we print that position as well. So at the end of this loop, the entire path has been printed, and then we finally print a new line character so that the cursor comes to the next line, and that's all that the main program needs to do. You can see that once the functions have been written, the main program is really simple, and somebody on reading this immediately understands what our algorithm for solving this particular problem is. So that's the end of today's lecture. In the next lecture, we'll start by discussing another important tool in programming, and that's the notion of pointers.